So the next part of this section is to figure out how do we find the mean for grouped data. And the reason this is important is we often are given group data and not the actual data values. And so we can't calculate the mean without this special process. Now, this is the process you have to do. And he's a little bit wrong. Somewhere he teaches how to find the midpoint of these things, and he's not correct on how to do it. So I'm going to teach you the correct way to do it, and we'll go from there. But in general, how you find the mean is you take the frequency of each class and you multiply it times the midpoint, and then you add up the sum of the frequencies. So this is the record high data from before, and they've still got the frequencies. What we're going to do is calculate the midpoints. Now, I take offense to his classes here. The classes should have a lower limit of 100 and an upper limit of 105 instead of this 100 to 104. So remember what we were talking about here is this was included and this was not inclusive, and then we put the 105 here and we go up to 110. We include the 105 in this class, we don't include the 110 here, and then we're good in terms of keeping track of everything. So I copied over what I think is a better version, although it's all tilted. Just ignore that. Pretend I did it perfectly. And now we're going to calculate the midpoint. So let me give you a little formula for how to calculate it. The midpoint of each class is equal to the sum of consecutive lower limits divided by 2. What does that mean, right? What is consecutive lower limits? It doesn't even look like I spelled it right, but whatever. So what does that mean? Well, consecutive means one after another. So if this is the first lower limit, the next lower limit is 105. That is consecutive to 100. And then 105 to 110, these two are consecutive lower limits. So if I want to find the midpoint of this class, I'm going to do 100, that's this lower limit, plus the next lower limit, 105, and divide by 2. This will get me the correct midpoint for this class. It ends up being 102.5. So we repeat for the next one. We do the exact same thing. 105 plus 110 divided by 2, and that equals 112.5. Fail. What? Who said that? I didn't say that. That equals 107.5. There we go. The next one is 110 plus 115 divided by 2. This one is 112 divided by 5. Now let's make an observation. How far apart are these two midpoints? Well, the way to do that mathematically is to do 107.5 minus 102.5, and we get 5. That seems familiar, doesn't it? We could look at the same thing here, and we could see that these are also 5 units apart. In fact, that's going to be true for every single midpoint. They're going to be exactly 5 units apart. Well, where did we see that last? Well, this is the width of our classes. So once you find your first midpoint, just add to it the class width, and you've got the rest of the midpoints all the way down. You don't have to keep applying this sum of consecutive midpoints formula. All right, so there's all my midpoints. Now, what I'm going to do is recopy this and put the frequencies next to it to make it all nice and clean, and then we're going to calculate the weighted mean. So to calculate the mean, now that we have all the midpoints for each class, we're going to do the sum of the midpoints times the frequency. In other words, we're going to do 102.5 times 2 plus 107.5 times 8 plus and so on and so forth up to the very last one, and then we're going to divide all of that by the sum of all the frequencies. So 2 plus 8 plus 18 plus 13 plus 7 plus 1 plus 1. If I recall, this should be 50 because these were the 50 states. Let me show you how to do this in Desmos, since that's what everyone I know has for free. You just have to log in. So we're going to go over here and we're just going to type that mess in. It's going to be annoying. 102.5 times 132 plus 107.5 times 8. And I'm going to pause and type it in. And okay, so I have the top numbers all typed in. I can just scroll through and you can see where I've got each midpoint times the frequency. And once I've got all that in, I'm going to put a set of parentheses and then hit my division sign so I can get the fraction bar. And I could put in the sum in the bottom, so the 2 plus 8 plus blah, 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 blah. But I know that adds up to 50. So here's my weighted mean. It's approximately, or it's equal to exactly 114.7 degrees. We should pause and ask ourselves, does that seem reasonable? Does that kind of fit what we would expect the center of our data set to be? Well, first off, note that it's between the minimum and the maximum, so at least that part's reasonable. And then if you look at where the majority of the numbers are, they're in the 102 to 117.5 range, and so this is within that range. It's possible that this 132.5 value is an outlier. Now, let's note one other thing. We did not use actual data values to calculate this mean. So the weighted mean is always an approximate mean. Is always the approximate mean because we are not using actual data values. Oh boy. So to drive this point home, what we did when we created these midpoints here is we said there were 18 states that had a high temperature of exactly 112.5. I don't think any of the data values were 112.5. But by creating this midpoint, we're estimating that all of the values within that class, the class of 110 to 115 is exactly equal to this. And it's probably a pretty good estimate of the value for each of those 18, like the average value of them all. So this is going to be a pretty good approximation, but you need to keep that in mind that this itself is not an exact value.